Hey, Mr. Ransberg here, and we're going to be looking at a couple of extra tree diagram practice problems. These have the, I'd say, level of dealing with good AP free response questions, how to break it down, how to analyze it, and really interpret what's going on. And this first one deals with the accuracy of drug testing. And it's a really interesting concept that we're going to talk about at the end on how the numbers in the prompt, what they really mean in the answer, and kind of the consequences that can occur from it. So in the first prompt, we have a company screens job applicants for illegal drug use at a certain stage in the hiring process. This specific test has a false positive rate of 2%, that sounds low, and a false negative rate of 1%, still a low number. Suppose that 5% of all the applicants are actually using drugs. And we randomly select an applicant. Given that the applicant tests positive, what is the probability they are actually on drugs? And that's our final goal. State, plan, do, conclude. What are we trying to figure out? We're trying to figure this out. And if we think about in symbols, given that the applicant tests positive, so what are we trying to find? We're trying to find the probability that given that you have a positive test, they are actually on drugs. They are using drugs. That's what we're trying to figure out. We're trying to find the probability that a person is using drugs given that the test comes back positive. So that's pretty, to my mind, shows the real accuracy level of the screening test is given that it's a positive test, the person was on drugs. So let's see what that final answer is going to be. So you have to outline what we know. So first thing I see is this, a false positive rate of 2%. So let me kind of write this off to the side. We have a false positive, so a false positive, and that rate is 2%, so 0.02. Now what does that mean? Well, a false positive means the person gets a positive test result if they are not using drugs. So this would be a positive test given that they are not on drugs. That's how we can interpret false positive. The next one says a false negative of 1%. And a false negative, and that's 1%, means they get a negative test. Given that they really are on drugs, they are using drugs, they are on drugs. So that's the first part. Suppose 5% of the applicants are actually using drugs. So right here, 5% of the applicants are using drugs. So that means people who are using drugs is 0.05. Well, people not using drugs. Well, then that's going to be a complement rule. So not on drugs is going to be 0.95. All right, so that's all the information we have from the prompt. Now, given that the applicant tests positive, what's the probability they're actually on drugs? That's the goal. So state, that's the green right there. That's what we're going to try and find. Plan, I'm going to outline what I have, and I did that on the screen. And now I'm going to create a tree diagram to figure this out. So now let's do it. So start off. Well, they're hiring somebody. So you're going to have all your employees, and we're going to start with all the employees. And those employees are either on drugs, they are using drugs, or they are not using drugs. Now, when you're looking at this, I go through and go, oh, that's a lot of writing so far. Could I define using drugs as D, and then automatically use D complement for not using drugs? I could if I would write it up here. Remember, if you want to use it, you have to define it. So I'm just going to leave it as is though. And I know my probabilities. We're told that 5% of the applicants use drugs. So I'm going to put 0.05 here. So that means 95 do not use drugs. That wasn't too bad. Now those people applied. They're either using drugs, not using drugs. Then they're going to get screened. And so they're going through their drug screening now. And now, when they're going through the drug screening is where we have the positive or the negative results. The positive or the negative results. So I've used these two, check, check. So now I need to use the false positive, false negative information that I have. Now, false positive means they have a positive test result when they are not on drugs. So they are, given that they're not on drugs, so I'm following this path, given that they're not on drugs, they have a positive test result. So I'm looking right here. This right here is 0.02. And so this is 0.98. A false negative is that they are on drugs. They are using drugs. Given that they're using drugs, they're going to test negative. So right there is our 0.01. And this is our 0.99. So there we are. There is the tree diagram that outlines this situation. Now we're going to have to figure out some of the things that we are finding. So if I want to calculate some of these probabilities, I'm going to go across the branches and I'm going to calculate it. And you can see now right up above, those are the calculations for each of those. And I wrote them down. And when we're going through, now we're going to figure out what each of these represents. That 0.0495 is the probability that the person is using drugs and testing positive. The 0.0005 is the probability the person is using drugs and testing negative on it. So when I want to go through and I want to figure this out, I want to find the probability that the person's using drugs given that they test positive. Well, if I think about that, that's going to be the probability that they are using drugs and positive over the probability that they are positive. That's it. Well, the first part is they're using drugs and they are positive. So that's going to be the 0.0495. That's this part right here. And I'll use the orange to highlight right there. That's the using drugs and positive. Boom. 0.05 times 0.99. Well, what about the probability of being positive? Well, here's our positive results. Well, let me use a different color to make it a little bit easier. Here's our positive results right here and right here. So I'm going to add those two numbers together. I'm going to take my 0.0495 and I'm going to add my 0.019. So that's the probability I'm looking for. So let's try this out. I'm going to do alpha y equals so I can type it in properly. I'm in classic mode, so let me go back for a minute. So let me hit mode. Let's go to math print so I can do my fractions and hit alpha y equals here. All right, so I get 0.0495 and I'm going to divide by 0.0495 plus 0.019 equals 0.7226. So approximately 0.7226. Now that is the answer to our question. Our question is, we want to know, so instead of writing it down, I'm going to cheat. We want to know the probability that the person is using drugs given that they tested positive. It is 0.7226. And that's it. Now, I used the fraction feature in the calculator because I enjoy using it. But if you are not using it, you need to be a little careful. You need to remember you are dividing by an object that's being added together first. So I need to put division and then a parentheses. And then type in my information. So if you're going to do it that way, make sure you include the parentheses so you get the right result. Now, the reason I wanted to talk about this example is because that's the probability the person is using drugs, given that the test is positive. So given that the applicant tests positive, that's a probability they're actually using drugs. So let me ask you this other question. What's the probability that they are not on drugs, given that they have a positive test? So this person was applying for the job. They go and they take a drug screening. This person is not using drugs. Not using drugs. but they come back and the test comes back positive. So what happens is these tests come back positive, negative. So given that the test comes back positive, what percent of those people were not using drugs? It's a very interesting question, because let's do the same idea. So I'm going to find the and first. The and would be not using drugs and testing positive. Well, that's the 0.019 over the probability that that is a positive test. Well, that's the same sum we have over here, that 0.0495 plus the 0.019. Now, this is interesting, so let me go over here, as I'm just going to copy and paste. So I'm going to grab this, and let me change it, the top, to 0.019, and let's see what we get. We get 0.2774 approximately. So this is approximately 0.2774. So what does this mean in the grand scheme? This company, when they get their results back and they have a positive test, given that the test came back positive, around 28% of those people were not on drugs. Around 72% of those people were on drugs. So I like this problem because it's a discussion problem. And by the way, these numbers, the false positive rate, the false negative rate, we said in the beginning, that sounds low. And those are low. But this is how conditional probability works. It's this idea that given that a scenario happened, given that they have a positive test, what's the probability that they're using drugs? Well, that was around approximately 72%, which means given that they have a positive test, what's the probability they're not using drugs? Approximately 28%. So this is a really, in my mind, eye-opening question on the accuracy of drug testing even, and what the end results are for it. So the next video is going to go over the airport screening problem.